Okay, for geometry 9.2, we are still learning rigid transformations, but today specifically we're going to talk about reflections. So I know that you probably know this, but a reflection is exactly what it sounds like. It's the flip over a line of an object. So the FL in the word reflection should remind you of FL in the word flip. So you're just going to flip it over a line. Now, the line that it flips over is actually called the line of reflection. And again, it does not change its size or shape, and that means it's a rigid transformation. So not changing its size or shape is what makes it rigid. Okay, I want you to look down here at these bolded lines. I'm actually going to give you the formulas. So if you're reflecting across the x-axis, so really quickly, this is your x-axis. If you are reflecting across the x-axis, so if something was here and it's going to now flip down here, so you're reflecting it over the x-axis, what happens is the x actually stays the same. And that makes sense because if you're going to the right 2 to go up here, you're also going to go to the right 2 to go down here. So the x doesn't change. It's the y that if it was going up before, it's going to go down now. So the y becomes opposite. So if this was 2, 2, it would be 2, negative 2. Okay, and then same thing except opposite if you're reflecting this time over the y-axis. So let's say something is here and it's going to flip over the y-axis over here. That would be x this time is the one that changes. So, and that makes sense because if it's negative 2, 2, then it becomes positive 2, 2 to flip over the y-axis. So these are the rules. If you're flipping over the x-axis, x actually stays the same. Y becomes opposite. If you're flipping over the y-axis, y stays the same, but x becomes opposite. All right, let's do just a few of these. This one is going to reflect over the x-axis, so that means the y is opposite. So we're going to take this whole shape and flip it over the x-axis. So what I would do is you could either list the coordinates and then find opposites of each of the y's, or if you know we're reflecting over the x-axis, look at the x-axis and see that w is 4 above. So we are going to move w to 4 below. And remember, once you place this, that is actually w prime because it is the image after we've reflected the pre-image. So m is going to be 1 further down here. That's m prime now. D is from the x-axis. It's 1, 2, 3, 4, 5 above. So we're going to go to the x-axis and instead put it 1, 2, 3, 4, 5 below. So, and don't forget your labeling. This is D prime. And then A is 1, 2, 3 above the x-axis, so we're going to put it 3 below the x-axis. And that becomes A prime. Do either regular lines or dashed, I don't care, it's fine either way, to show your reflection. Okay, we're going to reflect over the y-axis this time. S is 1, 2, 3, 4 away from the y-axis, so we are going to go 4 away the other direction and call it S prime. A is 3 away, so we're going to move it to 3 away and call it A prime. J is 1, 2, 3, 4 away from the y-axis, so 1, 2, 3, 4 more away is going to be J prime. And then T prime is just diagonally up from J, so we're going to go diagonally up the opposite direction from J to put T prime. All right, go ahead and connect your dots, either with dashes or with straight lines, and you should have a reflection over the y-axis. All right, a couple more here. These are all just what you'll notice is reflecting over the x-axis or the y-axis, but sometimes you may be asked to reflect over the x equals 3, for example, and you would just do it the same way, but instead of using the axis, you would use whatever line it's talking about. So this one, again, wants x-axis, which this is going to be weird. It's like taking a shape and flipping it over what it's already cutting through. So this is going to kind of reflect over on top of itself, because reflecting over the x-axis with something that cuts through the x-axis means it's still going to be on the x-axis. It's just going to be kind of reflected the opposite direction. So this is a good one maybe to write down our coordinates. So let's write down the coordinates of S. S is -2, 1. W is -2, 3. I think that's an I, is -5, -1. And then P is -4, -2. So if we are reflecting across the x-axis, remember what that means is the x is going to stay the same. So -2, -2, -5, and -4 are going to stay the same. But all of our y's are going to become opposite. So S prime is going to be -2, -1. W prime is going to be -2, -3. I prime is going to be -5, +1, because it was negative. And then P prime is going to become -4, +2. So that should help you when you're flipping something over, just to be able to make sure you get it right. So -2, -1 is now S prime. -2, -3 is now W prime. -5, +1 is I prime. And then P prime is -4, +2. So it's kind of a weird thing, but it just basically ended up flipping over itself. Okay, and then let's look at this last one. So this one is going to reflect over the y, and the same thing's going to happen here. Since we're reflecting over the y-axis, it's just going to basically flip over itself. So it's another good idea to go ahead and write down what our coordinates are. W is 0, 3. L is 3, -2. B is -2, -3. And then I is -2, +2. So remember, when we're flipping it over the y-axis, y is actually going to stay the same. It's the x that becomes opposite. So each of these x's are going to become opposite. Now, there is no such thing as the opposite of 0. So W prime is actually going to stay 0, 3. Okay, but the opposite of +3 is -3. So for L, it will be -3, -2. For B, it will be 2, 3. And for I, it will be 2, 2. 2, 2. Oh, this should have stayed negative. Sorry about that. The y stays the same there. Okay, so let's go ahead and plot these. So for W prime, it's 0, 3 again. W and W prime are going to stay where they both are. So I just added a dot to it, but it's going to stay right in the same spot. L is -3, -2. So that's going to flip over here and become L prime. B is 2, -3. So that's going to be B prime down here. And then I is 2, 2. And that would be I prime. So all it's doing here is basically flip-flopping over just itself. The shape should stay the same. The size should stay the same. It just got flipped over. Okay, and that is reflections.